Hello learners and welcome to today's class. Today we will look at some of the common soil problems and solutions. A recap from our previous class is that soil requires a lot of aspects like it requires cations, it requires some nutrients, soil organic matter, its pH must be balanced, and an excess of any of those requirements of the soil could be harmful to the soil and also the plants. A deficiency of those requirements also could be harmful to the plants and also could affect the soil formation process. Some of the common problems we will look at include the lack of topsoil and low organic matter, the presence of a lot of clay that leads to compaction and poor drainage, erosion by wind or water, the presence of obstructions in the soil, incorrect soil pH, and the presence of low nutrients, hydrologic discontinuity, soil temperature, and soil contamination. How is it that plants get to have low organic matter? It occurs, for example, in crops that are found in arid areas where the vegetation is very limited, and that once plants are harvested, the remains, the plant residues are never returned into the shamba. Instead, they are used for other purposes such as plant to feed animals and also as a source of energy through firewood. In another case, the alteration of urban and suburban areas during development such as construction, infrastructure, road, railway construction, soil is turned and inverted so that subsurface horizons are brought to the surface, and therefore the topsoil is not present at all. The soil that is turned and overturned and inverted has got very few limited organic matter and is very prone to being washed away, considering that there is no vegetation that can grow on it. Some of the management approaches that can be used to ensure that we regain a topsoil horizon is that we can mix with compost and ensure we retain plant residues once they are harvested instead of using them for firewood and other purposes such as animal feed. We can also manually add a topsoil that has been bought from a reputable topsoil dealer. This has been done especially for those people in the business of selling flowers and seedlings, where they get, for instance, red soil and use it to top the places where they grow their orchards. The second problem is on the presence of a lot of clay, compaction, and poor drainage. Usually, clay soils have got the ability to retain a lot of water, but once they have been stepped on, for instance, when people are cultivating, animals are passing by, farm machinery, vehicles, and garden equipment are used on the farm, it tends to get compacted. When it is compacted, it means that it is poorly aerated, has no air spaces, water and nutrients cannot pass through. As such, it means that in the presence of irrigation and in the presence of rainfall, the water only floods. It becomes waterlogged and cannot infiltrate to be accessed by the roots and the plant ultimately. Therefore, the plants are likely to wilt or even to dry up in extreme cases. Also, in soils that are present in arid areas, they are very prone to compaction since there is little vegetation on them, and most of these people practice pastoralism, so animals tend to step on the farms. What are the methods that you can use to test for compaction? Number one, when soil is moist but not wet, after a few days of rain, then you should be able to push a stiff steel wire up to about 12 inches. Without being able to do that, the soil is considered to be compacted. Another test you can use is the percolation and soil drainage test. In this case, you dig a big hole of about 12 by 12 inches, then you fill it with water. The next day, the hole you fill the water in the hole again. All this water should be drained in 8 hours if the soil is not compacted. Otherwise, the soil is compacted. The last test you can do to assess if a soil is compacted is you can dig a hole and then you fill it with water. And after 12 hours, fill it again. If the water does not drain within 2 3 hours, then the soil is considered to be compacted and therefore considered to have poor drainage. What are the solutions to poor drainage, compaction, and a lot of clay soils? Number one, you can increase the aeration of the soil by trying to loosen it and by shunning compaction. This is what we said when we were recommending the use of zero tillage in our first class, that if we avoid disturbing the soil, then the soil structure will remain as natural as possible. Number two is that we can increase the amount of soil organic matter through adding plant residues, planting cover crops, and mulching. Number three, we can add fine sand particles if the soils are too clay to ensure that we enhance the drainage or also improve the structure. This has been shown to work, but it does not work always. Number four, another solution that we can do is by adding gypsum, which is a mineral that is important and provides calcium and sulfur. These calcium and sulfur, as we saw in our previous class, were examples of the macronutrients. However, the challenge with these two is that they are likely to affect the soil pH so that it becomes so basic and therefore so saline. Another thing we can do is that we can select plants that are adapted for poorly drained soils. Such examples are like the planting of cowpea, which has been known to ensure that it breaks the compacted areas since it is deep rooted. Lastly, do not dig or rototill or walk when it is wet. This is a common mistake that most farmers do. They dig, cultivate, plant, work on, or use animals to cultivate when it is wet. And this has been a major challenge since it enhances compaction. And with compaction, you are likely to get the soils less and less aerated and hence poorly drained. The next problem we will look at is erosion. Usually, if the soil is not well covered and it is not well vegetated, it is likely that it can be taken away by either water or wind. In this era of climate change where we expect that there is extreme weather, the events of erosion, either by wind or water, have become so extreme. For instance, when there are hailstorms, the topsoil in non-vegetated or limited vegetated areas like arid areas is likely to be carried away by the wind. In events of extreme rainfall, the soil is likely to be taken away by water to other areas. This leads to the removal of the O and the A horizons that are important for plant nutrients and plant growth. How do we manage erosion? Managing of erosions can be done by, first, you can monitor the signs of erosion, such as the presence of channels or the presence of splash drops, especially in areas that do not have adequate vegetation. Another thing we could do is by adding a lot of soil organic matter, mulching, growing cover crops, and ensuring that the soil at any time is well covered. This can be done by planting a lot of trees. The next problem we will look at is the presence of rocks, buried debris, or obstructions. This occurs in areas that have been previously used for other purposes. For instance, areas that have been used as landfills or dump sites, they have remains of solid waste, and these could be obstructions to plant growth. What we can do in such a scenario is to ensure we explore the areas we know that have got those obstructions and manually remove them. In areas where construction has been going on, rocks can be buried during the turning and inverting of soil. These can be can be felt manually and removed to ensure that during plant growth there is no obstruction to the roots for efficient growth and passing of nutrients and soil. The other problem we will look at is the presence of incorrect soil pH and low nutrients. This could be as a result of the misuse of fertilizers, which we are going to look at a later stage in this class, or the presence of what we refer to as nutrient mining. Over a long time, most of the soils in arid areas have been used and reused so that the nutrients that were present have already been exhausted. And those that are remaining, they are too few and very inadequate for plant growth. In such a case, you will find that soils are on the extreme side. They are either very basic or very acidic. For instance, soils of the coast and soils of arid areas are very salty. This is as a result of accumulation of salts over time during the process of evaporation and during the processes of leaching when it is raining. Remember the processes we looked at when we were looking at soil formation processes. The soil nutrients could either be lost as a result of transformation or during the processes of leaching. How to manage the incorrect soil pH and the presence of low nutrient is through the application of fertilizers and other soil conditioners. We will look at what fertilizers, examples of fertilizers, and examples of soil conditioners. Hydrologic discontinuity is another problem of soil, common problem of soil, which refers to the intentional and unintentional changes on the particle sizes of different soils at various horizons. This occurs during the development of soil, such as the turning during construction, where such large amounts of soil are turned and returned so that the soil profile does no longer is no longer is no the soil profile is no longer in its original shape. This in essence results in waterlogged soils that are poorly aerated, and roots that cannot access the soil water or the nutrients. Therefore, it is not adequate for plant growth. The management approach we can use is by ensuring that each time we keep on composting the soil so that we add plant residues and animal waste or plant remains to ensure that there is adequate soil organic matter to construct the soil structure, reconstruct the soil structure, and ensure that there is microbial diversity. The last problem we will be looking at is what we refer to as soil contamination. In this era of industrialization, many contaminants such as heavy metals, for instance lead, arsenic, chromium, and some plastics such as polycyclic aromatic hydrocarbons, the use of agrochemicals such as pesticides, and the presence of animal and industrial waste in cases where there is open dumping and landfilling. These can find themselves their way into the soil in this era of industrialization, and they are very harmful to the soil. They alter the soil characteristics, the physical chemical characteristics of soil, what we refer to as the cation capacity and the pH. What we can do in such a scenario, we must investigate or test the soil to ensure that it is contaminated or otherwise. Usually, healthy soils have a lot organic matter, and this organic matter helps buffer the soil. That is, it ensures that physical chemical characteristics of the soil are, are not as much altered by the presence of other foreign chemicals such as heavy metals or plastic or agrochemicals. Therefore, soil contamination can be bioremediation. Bioremediation can use one, it can use they can use enzymes that are made from the lab or from microorganisms such as fungi, bacteria, and algae, and you can use them to ensure that these heavy metals and other foreign materials are digested and broken down to unharmful substances. Alternatively, you can use other crops. Some crops have the ability to accumulate foreign chemicals that are harmful without causing harm to the crop and ensuring that the environment is clean. Another approach we can use is that some microorganisms such as bacteria, fungi, and viruses have been used to take up these waste, these kinds of chemicals such as heavy metals and plastics, and eliminate them from the soil to ensure that plants grown in such land are healthy. This bioremediation process is a common practice because it ensures that there is environmental conservation and no chemicals are used during the process of eliminating other chemicals. It ensures that pollution is limited. The other problem we will look at is soil texture. Remember from our previous class, we said that the ideal temperature for growth and germination of crops is between 18 and 24 degrees centigrade. Beyond this, the plants would not germinate, or the plants would germinate and have stunted growth. However, it is good to note that some specific crops have specific ideal temperatures. For example, beans will not germinate or grow well if the soil temperature is less than 60 degrees Fahrenheit and, or is greater than 95 degrees Fahrenheit. Seed germination and root growth can also be inhibited if the temperature is very high or very low. Soil, soil temperature also affects the growth of weeds and the infestation of crops and soil by pests. Therefore, to ensure that the soil temperature is well regulated, a farmer should have information on the kind of crop they are growing, their ideal temperature, the weeds that mostly affect the particular crop, and the herbicides that can be applied to ensure that the weeds are eliminated without affecting the temperature or altering the temperature to greater degrees that can cause negative effects on the crop. Of all these problems we have discussed, we have to affect soil fertility. And once soil is infertile, it cannot be used for agriculture. Therefore, we need to understand what are the ways we can improve soil fertility, even in the era of climate change where we are saying we are prone to erosion and we are prone to processes such as compaction and water logging. Even in the era of soil degradation where we are having a phenomenon where soil is becoming altered chemically and physically so that it is no longer capable of growing crops. Even in the era where we have mined the nutrients, most of the nutrients in the soil without returning. Imagine a scenario where you used to eat, you never eat, but you are expected to work. It's not possible because you do not have the energy. It is the same procedure with soil. You mine so much of its nutrients until it gets to a point that it is not capable of growing plants. Usually, soil degradation is as a result of the lack of soil organic matter, which we refer to as both the O and the A horizon. Remember from our previous class, and the inadequacy of nutrients and other trace elements that are important for crops. This has to do with the assignment I gave you. It also has it is also as a result of the alteration of pH. Usually, the ideal pH for plant growth is between 6 and 6.8. That is, it is very neutral. It is not too acidic, not too basic. And these aspects also, they have the capacity to influence the structure of a soil and its microbial diversity. To ensure that fertility is improved in a soil, we have to do a soil test, as I mentioned the last time. That the basis of improving soil fertility is doing a soil test and understanding what are the factors that are influencing soil fertility and the status of your current soil. Is it too acidic? If it is too acidic, what can I add? If is it too basic? If it is too salty, what can I add? What minerals does it lack? Does it have too much nitrogen or too much phosphorus? Is it compacted? Does it have enough organic matter? Therefore, some of the aspects that influence fertility include soil organic matter, the rate of acidity, the texture, the depth, the water holding capacity, and the cation exchange capacity. It is from these aspects that you will note that soils of one area compared to another are of different quality and different fertility rates. However, the solution of improving soil fertility is through fertilization. But wait, what is fertilization? Fertilization is the use of fertilizers. What are fertilizers? Fertilizers are a type of soil conditioners. They are compounds that are usually introduced to plants to ensure that you promote growth or you enhance the yield rate, and they can either be applied in the soil or to be taken up by the roots, or they can be fed on the leaves through spraying, what we call as foliar feeding. Fertilizers typically provide a variety of nutrients. Mostly, they are the major nutrients such as nitrogen, phosphorus, and potassium. There are also secondary plant nutrients such as magnesium, sulfur, and calcium, and some micronutrients that can be provided through fertilization. But wait, we said fertilizers are some soil conditioners. What are soil conditioners? They are soil amendments. Soil amendments are additions or subtractions that are made in the soil to ensure that the soil is healthy and adequate for plant growth. The type of a soil conditioner depends on the soil composition as at that time, the climate, and the type of plant. For example, we say that some specific plants have got a specific ideal temperature. It is at this stage we say that temperatures influence the weeds that are used. Therefore, for one crop, from one plant to another, we can use different herbicides to ensure that the temperature is not altered. When you look at the climate, when it is dry, there are some soil conditioners that can be added to soil to ensure that its water retention capacity once it rains is increased. The composition of soil. Sometimes soil is deficient or in excess of something. For instance, we said when the soil pH is too salty, you can add gypsum. Gypsum ensures that the soil is, the soil pH is buffered. When the soil does not have enough macro or micronutrients, you can add a fertilizer or increase the amount of soil organic matter in the crop. Those are types of soil conditioners or soil amendments that are meant to improve the soil for plant growth. A conditioner or a combination of conditioners are used. For example, fertilizers add depleted. For example, fertilizers add deficient plant nutrients. Materials such as compost, and we will see this in the next class, they ensure that the water can hold more, the soil can hold more water and its structure is fine. Lime can be used to make a soil less acidic. Gypsum ensures that the soil is able to improve its cation exchange capacity so that nutrients are available in the ionic form for the plant and also improves the soil structure. Sometimes some soil inoculants can be added for legumes to ensure that they improve the amount of soil aeration. What are classes of fertilizers? Fertilizers are classified into two. They can be organic or inorganic. Organic, they are fertilizers that are carbon and hydrogen based, while inorganic, they are mineral based, exclusive of carbon. The organic fertilizers can be naturally occurring, is in the case of feces, urine, some peat, seawood, and manure, just to name a few. They can also be manufactured organic fertilizers such as dried blood, bone meal, and compost, among others. When you look at the case of inorganic fertilizers, those that are not carbon-based, they can be naturally occurring, as is the case of limestone and other rock phosphates that are found in the B horizon, what we called as the bedrock in our previous class. They can also be manufactured chemically, such as is the case with ammonium nitrate, potassium sulfate, and superphosphate. When you look at this context, what I have circled here, what is the naturally occurring organic fertilizers and the manufactured or chemically synthesized inorganic fertilizers, those are the common soil amendments that are used to ensure that fertility of soil is enhanced. The other aspect we will look at with regard to soil fertilization is composting. What is composting? It is the biological decomposition of organic materials by microorganisms, and these microorganisms could be either bacteria, fungi, or viruses. The result is what we call as a dark, somewhat nutrient-rich soil conditioner, what we refer to as humus, or what is consisted in the O and the A horizons of a soil profile. The benefits and the mechanisms of composting, we will do them in the next class as there are quite a number, and this is a very important aspect in terms of soil management. I hope now you can understand that some of the problems in reference to soil management. This could be what we have referred to as low organic matter, compaction, erosion, the lack of consistent pH, the presence of altered chemical characteristics of soils, extreme temperature, and soil pollution. Thank you.